The broadcast is now starting. All attendees are in listen-only mode.
Good evening, welcome. We'll be starting in just a few minutes. We're just letting people come in from the waiting room. But while you're waiting, you may want to take a look at your screen and see how the webinar, GoToWebinar works. There's a panel, a side panel on your right side of your screen, and you should see two handouts. These handouts are about some upcoming events, so if you're interested, you can click on it to download it. One of the events is about our next event, next Wednesday. It's an online event. It's called Drop, Water Connects Us All. It's a virtual film screening followed by a panel discussion about how a warming climate can have consequences for us all. And the panelist discussion should be very fun. It's with three renowned Montanans, Hillary Hutchinson, a fly fishing guide from Columbia Falls, and Hillary Lynn, who's a world champion and Olympic alpine skier, and the executive director of Montana Trout Unlimited, David Brooks. Again, this event is next Wednesday, April 13th at 7 p.m. and the information's on that handout. The other handout is just a little summary of all of our in-person events here in Bozeman during Earth Week. We've got one on Thursday, another one on Friday, and two events on Saturday. So check that out. So if you've just joined us, welcome. We'll be starting at the top of the hour in just 2 or 3 more minutes. So you can just get yourself familiar with the screen with the side panel for GoToWebinar if you'd like. As I already mentioned, there are 2 handouts you could download about future events. Also, just check out on that side panel, there is a little place with a little hand, and you'll be using that later if you want to ask a question, or you can also, if you can locate the question section in the right side panel, you may want to use that too later on for answering questions for our speaker tonight, Randy Hafer. Good evening for you who have just joined us. We're so glad you're here, and we'll be starting in just a few minutes. I think 2 minutes now, just letting people get in from the waiting room and get signed in. And once again, for the 3rd time, for those who have just arrived, we have 2 handouts that you can download. If you click on them, you can download them on your computer, and it's just information about upcoming events. We have a really interesting short film screening with a panel discussion a week from today, another online event called Drop, Water Connects Us All. This film was produced by our own Montanan, Hillary Hutchinson, along with Patagonia, and it was first released last year for Earth Day. Sorry, I'm going to get some water. Hello, hello, for those who've just joined us. We'll be starting in 1 minute, just letting a few people get in and get situated here. You can just take a look at your right side panel, get familiar with that. You'll be using that later if you want to ask questions. Also, you can download the handouts. Just handouts are about some future events you may be interested in. So we'll just take 1 more minute here, let some people get in, and then we can't wait to get started. It's going to be a very fun, interesting talk. I'm so excited about having Randy Hafer here tonight. Welcome, everyone. So glad you're here. If you just came in, we're starting in just a few seconds. I'm just going to give us a few more seconds, and then we'll get going here. We're at just past the top of the hour.
I think she's going to do all this first.
So, and we'll get Randy muted for now, perhaps. So, okay, well, great. Good evening. We're so glad you've joined us tonight. Gallatin Valley Earth Day is really thrilled to have Randy Hafer of High Plains Architects in Billings with us tonight to talk about an innovative and cost-effective water system that dramatically cuts water usage. Now, I first heard Randy at a Montana State University sponsored talk a few years back, and frankly, I was just blown away. So I think you are in for a real treat tonight. Randy's talk is the third in a series of online talks that we've held in 2022. And if you'd like to view a recording of the previous talks, please go to our website at www.gallatinvalleyearthday.org, and you'll see a little tab at the top on the right-hand side that says YouTube. Just click on that and you can see the recordings. My name is Ann Reddy, and I am the chair of the Gallatin Valley Earth Day Committee. Gallatin Valley Earth Day's theme this year, if you don't know already, is celebrating water stewardship, past, present, and future. Now, we chose this theme both because 2022 is the 50th anniversary of the Clean Water Act, and because we are facing some difficult challenges with our water right now and in the future. Our unprecedented drought, a warming climate, and pollution in our rivers are all issues facing us today. And the future also holds concerns. In fact, the city of Bozeman estimates that we will not have enough water for our growing population by 2033. So with this in mind, we are glad you've joined us to learn about an innovative solution that will help us reduce our water consumption. But before we proceed, I just wanted to thank our premier sponsors. They are Gallatin Subaru, Volkswagen of Bozeman, and the city of Bozeman, and our stewards. Those are Sacagawea Audubon Society, Bridger Bowl Ski Area, Happy Trash Can, and Root Cellar Foods. Without their generous support, we would not be able to bring you tonight's program. Also, a big thanks to Sacagawea Audubon Society for providing their webinar platform for tonight's program. And then lastly, this program is only running smoothly due to Travis Kidd's excellent technical support. Thank you, Travis. Before I introduce Randy, we're almost there. I wanted to let you know that you will have an opportunity to submit questions during his talk and after his talk that he will answer at the end of his talk. So there are two ways to submit a question. You can either use the raise your hand feature and then we'll call on you and you can ask it yourself, or you can type in the questions in the questions section on the side panel. So with that said, I'm very pleased to introduce Randy Hafer. Randy Hafer is a co-founder of High Plains Architects. He is an architect, a developer, and a thought leader committed to environmental sustainability, urban revitalization, and historic preservation. Randy is a licensed architect and LEED accredited professional with a building design and construction specialty. Since founding the firm in 1999, High Plains has completed 11 certified historic tax credit projects, 13 LEED Platinum certified projects, and 1 Living Building Challenge certified project, Montana's first. Randy was made a fellow of the American Institute of Architects in 2014. A Billings, Montana native, Randy holds a bachelor's degree in architecture from Stanford University and a Master of Architecture degree from Yale University. So with that, I'd love to hand it over to Randy. So Randy, if you can please take it away.
Okay, thank you, Ann. I really appreciate the introduction and looking forward to talking a little bit about water issues in this, well, in the state of Montana and in Gallatin County in the world. And you're absolutely right that we're up against some really interesting challenges now and in the near future. So let's just move into it here. Okay, so I push the button and nothing happened. What am I doing? There we go. Okay. So a little background. How did we get here? And it's interesting to think about this. So we've just divided this short timeline into 3 categories, but pre-industrial really goes from say 2 million years ago to the dawn of humankind to about 1750. So during that pre-industrial period, populations were generally dispersed. There were very few large cities, and people moved around mostly on foot, but with horses to a certain degree. And water wasn't a particular problem. There weren't that many people. They were dispersed. They wouldn't gather someplace where there wasn't water. And so this is a very different time than we have today. Then starting roughly the middle of the 18th century, the Industrial Revolution began. And really what the Industrial Revolution was about was the big idea that, gee, if we burn coal, we can heat up water into steam, and we can make machines that operate off of steam. So during that beginning, really at that time, cities started to grow. Industry began to take a different kind of shape than it ever had. Instead of things being built individually, there began to be processes for aggregates of people to build lots of the same kinds of things. As cities were growing, housing was a problem, sanitation was a problem, the pollution was horrible. But people still moved around on their feet, and with a greater degree now with horses. And then we get to, starting with 1860, the oil era, and I'm going to hit the last three bullets first, because the oil era, which is 1860, basically to 2060, I'm already putting an end date on it. That's an age of unintended consequences, a time of great madness. Because what changed? Well, what changed is we went from burning coal, which made a lot of pollution, that enabled a certain kind of machine to happen, to using petroleum and burning most of it, made for more efficient machines compared to what we'd had in the past. It led to the rise of automobiles. It led to the rise of really everything, to the point that our society, modern society, is completely dependent at this point in time on the burning of fossil fuels. And the consequences are all unintended. But among other things, if you what's occurred is that populations have aggregated. Now we have very large cities, that most of which sprawl all over the place. Affordability and accessibility continue to be problems, and increasing problems. And now, of course, we've got global climate change coming along and really impacting not just individuals, but the entire planet. And so the thing that's important to understand about this, and I don't have my little graph on here, but if we were to chart this, the population with a population axis and a time axis, we would have population not changing very much, growing very slightly over several million years until you start to hit 1750, and then it starts increasing, and you go from more or less a horizontal line to the beginning of the oil era, and it starts to just shoot up. And you can chart all kinds of things that have changed since that time. And the graphs all overline the extinction of species, the increasing temperature of the climate, all those kinds of things align with the burning of fossil fuels. So what that means is now, instead of having dispersed populations that can find water, we end up in situations where everybody's aggregated, and the climate is changing and drying out in certain places, and we don't have the same kind of access to water that we had. So why does all this matter? Well, obviously, if water is fundamental to life, and if we don't have adequate water for people to live, then we have a big problem. Now, another thing that's important to understand is that the current population on the planet is somewhere around 7.5 billion people. And we're the only species on the planet that has the capability to completely overwhelm our support system. So we've got any other animal, when they exceed their range, something happens, they die off, and they go back to a population that particular area can support. We don't have that limitation. Maybe we do. In any case, we have this situation where we're really overwhelming the planet. The amount of water on the planet is not increasing. The amount of water that we have to use is being degraded. And in some cases, it's not available in the same way that it was through rainfall. Also, sprawl development, these really large cities that require that water be delivered become increasingly expensive and complicated to get water to all of those locations because of the fact that they're trying to expand, or those systems have to extend over such a great extent of area. And so as the Apollo 11 astronauts discovered, Houston, we have a problem, and we do have a problem, and it's a very real problem. So if we take a glimpse at the future, maybe we've got Highlight Lake. That's an important water resource for the Bozeman area. These, of course, are not necessarily that the lake is drying up at the moment, but it does go up and down. And so you start to see what it looks like as the water would go down. And you've got Bozeman as a green city, or maybe Bozeman ends up as a brown city. So these are the kinds of things that obviously we don't want to see, but we really need to be doing some things quite differently than we are doing if we want to avoid total catastrophe here. So what can we do? What can we do now? And first of all, we can be plump grapes or we can be raisins. And I think probably most of us would prefer to be plumped up. So the approach that we've taken to this issue starts with these kind of simple ideas. First of all, it's think big. And part of thinking big means thinking outside of the box in terms of the way we've been treating water, delivering water, even thinking about water. Also, because we're embedded in a system that frankly isn't even very old, is about 50 years old, 60 years old maybe, we need to start rethinking that system, and it's easier to start small than redesigning the entire system all at once. But you start small, we try some things, you learn from those things, then you try again, and then you repeat the whole process, because maybe across the Gallatin Valley, one idea isn't going to work completely over the entire county. Ultimately, our goal here is to save the planet, though, and that, of course, includes every particular place on the planet that we inhabit. And so now I'm going to give you, I'm going to look at an example of how we approach this. So this is my wife's and my house. We call it the Urban Frontier House. We do that specifically because, as I pointed out, I mean, most of the world's population now lives in cities. So for me, it was very important that we see what we could do in terms of building a house in the city, in an existing older neighborhood, on a small urban lot. This is 50 by 140 feet. That's completely self-contained and completely self-sustainable. So you can see the side view here of the house. We collect, well, I'm going to kind of jump back and forth actually between these next two slides. So this one is a diagram showing how the house works a little bit, but I can say that this house, again, it's in the city of Billings. It's an older neighborhood. We're just a couple blocks from downtown. We don't have any city water. We have no city sewer. We don't have a well. We don't have a septic system. We don't have gas. We don't have a heating system. We don't have a cooling system. And although we're a little bit warmer than Bozeman, we're still in Montana. And so we're figuring out ways to work with our climate, work with nature, and then, of course, work with the building to take care of all of the needs that we have within the house in order to make it work for us, be habitable for us, but also not be a cave. I do have a wife, and she was never a big fan of that idea. So we've got to have the house be comfortable by the standards that we've gotten to be used to. So you can see on the right, and I'll flip back to the other photo, so it's now on the left, but we've got a 6 kilowatt solar array on the house that generates all of the power. In fact, generates more than all of the power that we need to operate the house on an annual basis. You can see also that we've got 3 rain barrels along this side of the house, and there are 3 along the north side of the house. So all of the water that we use in the house and on the site is collected on our roof. Now, most of that is rainfall. Obviously, snow melt we can collect as well. But one of the things we learned is that with a steeply pitched roof, a lot of the snow over the main part of the house will slide off. So we don't get all of that. But we still, it turns out, have way more than enough water to make our system work. Whoops, sorry, wrong way. And so The way that we have this working, again, I'm going to focus now on the water, but all the water is collected on the roof. It comes down into the gutters around the perimeter of the roof, into the rain barrels, which are all connected underground, and then feed through the basement walls into our storage tanks in the basement. And that next one's mixed up because from the storage tanks, the water goes through the pumps and filters to a pressure tank. From the pressure tank, it goes to all the potable uses. That's faucets and sewers, and showers. Now, and one of the things that was really interesting to me about this process of designing this, there were some products on the market that address these kinds of, how do you collect rainwater and treat it to be able to get it to a potable condition that you can use for drinking. And the systems that were on the market were really complicated, very expensive. Some of them actually were actually water consumptive. And I realized that they were all designed for kind of a municipal scale water treatment system, assuming the worst, that you've got water with fertilizers and hydrocarbons and all kinds of nasty things in it. And it dawned on me that rainwater, moments before it hits the roof, is distilled water. So from the point that it drops out of the cloud to hitting the roof, there could be something in the atmosphere that it picks up. There could be dirt, or maybe a bird pooped on the roof that it picks up. But fundamentally, it's not very polluted water. And so we don't need such a complicated system to clean it up, filter it, treat it, and make it potable. And so our system actually is pretty simple, as you'll see here in a minute. And then in addition to using the rainwater, which we use for potable uses, we collect all of the drain water. So the drains from the sinks, the showers, the dishwasher, the laundry, the washing machine are all collected and run through an initial treatment facility that I'll show you here in just a second. And from there, it's pumped into a storage tank. And then from the storage tank, again, it goes through a set of filters and pumps to a second pressure tank. So the two systems are kept completely separate. And then the gray water is used for non-potable uses. So it's used in the washing machine, the dishwasher, a little bit for toilets, and then for irrigation. So ultimately, every molecule of water that we collect is used at least twice, some more than twice, but all of it stays on site. So eventually it all ends up as irrigation water and is used by the plants and soaks into the ground. Now for black water, that's the composting side. Our toilets are all connected to a composter, which is actually made in Montana. That material is composted over actually a fairly long period of time. The compost ultimately is then returned to the ground into the gardens around the house. And so everything within that whole cycle starts on site and stays on site. Now, another important thing is that in our house, as we've used this system now for we're closing in on 6 years, our average water consumption, this is my wife and I, and we have guests and overnight stays and all that kind of stuff, just like anybody else. But the average per capita, that's based on the two of us, is 10 gallons a person per day, year round. So it's 10 gallons a day per person in the wintertime, and it's 10 gallons a day per person in the summertime when we're irrigating. Now in Yellowstone County, well, actually it's the city of Billings. The city of Billings, the average per capita water consumption, residential water consumption, is about 86 gallons a day in the wintertime, and it increases to between 120 and 130 gallons a day in the summer. And that huge difference is due to lawn watering. So we irrigate, we don't have any lawn, but we do have pretty lush gardens. We grow a lot of our own food, and it's all from the same water. It's all part of that 10 gallons. So they're right there. I mean, if everybody in Gallatin County could go from what I'm sure is something similar, 80 to 90 gallons a day down to 10, then all of a sudden you can accommodate 9 times as many people. Now, whether you want that or not is another question, but the point is that it didn't require any change in lifestyle for us to reduce our water consumption by that amount. Now, part of it, of course, is that we use every molecule twice. Another part is that we have very low flow fixtures in our house that our lavatories in the bathrooms, their maximum volume is 0.5 gallons per minute. The building code allows 2.5 gallons a minute, but who needs 2.5 gallons a minute to brush your teeth? We don't have, I can't even deal with faucets that let that kind of water out anymore because it's so pointless. Our shower heads are 1 gallon a minute, again, versus 2.5. The code allows our kitchen sink. It'd also be 2.5, but it's 1.5, and it's also variable. So we can turn it back when we're just rinsing things. We don't have to have that much water flowing. But the key thing is that in a typical house, the amount of fresh water that has been treated and transported to your house that's used for toilet flushing is usually in the neighborhood of 40 to 50%. So if of your 86 gallons, almost half of that is toilet flushing. And so how much sense does that make? Where we've spent all this time to treat the water to potable standards, to transport it, pump it, store it, the whole system, and then we poop in it and send it right back down down the sewer to be retreated again. So our system doesn't have any of that because we do have a flush toilet. They use a pint per flush, and it all goes into the composting system and is dealt with separately. So all of these things in combination have been able to reduce our consumption ninefold or more over the typical user in Billings. This is what our system looks like in our basement. It's a 900 square foot basement. It's filled up with water tanks. The green thing is the gray water biological treatment unit, and the two blue pressure tanks are standing in front of the blue composter. What we now know is that this is way overbuilt. We have 5 1,500 gallon tanks that store rainwater. That's 7,500 gallons of rainwater. And then we have 3,000 gallons of stored gray water that we use, again, for those secondary uses and ultimately irrigation. And I think we have it tuned now so that we will run out of gray water for irrigation about the time we run out of irrigation season. And then we will, over the course of the wintertime, fill that back up so that we don't have to overflow anything. These look like it's bulky. There's no question it's bulky, but these are really pretty simple components. I mean, they're big tanks that store water. The composters are big tanks that compost waste. The gray water thing is actually more of an industrial unit, and so our newer designs have something much smaller than that. And what you can see in the left-hand photo, kind of in the left-hand corner right in front of the green tank, is where the pumps and the filters are. These are all pretty simple filters. There's some particulate filters. There's an ultrafiltration filter, which is a very fine micron filter, and there's also charcoal and an ultraviolet light that disinfects the water. And we have exactly the same treatment that happens with the gray water before it's used. In some future iteration, I'd really like to get to a place where the gray water and rainwater don't have to be treated separately, but we're not quite there yet, and certainly not from a regulatory standpoint. So anyway, that's kind of what we have. And I would say that last summer in Billings, we were about kind of normal precipitation through the end of May, and then until the middle of August, so 2.5 months, it was really quite dry. We had a little bit of rain, but not very much. We were way behind normal precipitation during that period, and we started at 7,500 gallons in the rainwater tanks, and 2.5 months later, we were down to 6,600 gallons. So you can hardly even tell. We could have far less storage and still have way more than adequate storage for our needs. And by the way, if you don't know, Billings average precipitation annually is about 13.5 to 13.75 inches. I think the Bozeman area in general is a little bit more than that, but not a significant amount. And the thing is, 7 inches of rain fills these tanks twice. And that's the lowest recorded rainfall that we've had in our area. So we could be down to half of that and still fill it up every year. I mean, if we only got 3.5 inches of rain a year, we would have enough capacity to still continue to be completely on our own. So we use some of the irrigation water we use for interior. We've got a garden room. This also serves as a passive solar collection space in the wintertime. It's quite lush now. These are some older photographs. We can also grow food in here in the winter. And I was looking for opportunities to be able to, really frankly, to use some of the gray water in the wintertime. We are saving most of it up because we want more of it in the summer, and it doesn't really take too much. So it's kind of a nice feature in the house. It also just does some other things for us. And then this is the outside. So when I said irrigating, I meant irrigating. It's all drip irrigated. It's all controlled. What you're seeing in the middle photograph is native plants and or adapted plants that are low water plants that grow in this area with very little water. And so you can have a quite beautiful lawn. You'll notice to the left there's some red rocks, to the right there's some other rocks. We don't have grass as a ground cover, but we do have these native plants. We also have fruit trees and berries. So the photograph on the right, kind of down towards the bottom of that, are raspberries and haskell's and blueberries and all this stuff. And then on the left, we've got tomatoes and all kinds of vegetables in the raised beds. And so these gardens are just intense, and they love the water, they love the sunshine, they love the whole thing, and we're able to do all of that and still stay within our 10 gallons of water per person per day. So there's no change for us between when we're using the water in the wintertime and when we're using the water in the summertime. And I think, let me see here, kind of on target, so I can take some questions at this point, and I would be happy to do so.
Okay, hi, I'm back again and unmuted. So Randy, first of all, I just wanted to thank you so much for a really interesting and thought-provoking talk. It was really interesting, and I'm sure a lot of people are going to have some questions. Just want to remind you folks again that you can go to your panel on the right and do ask a question in two ways. You can quote raise your hand by clicking on the raise your hand symbol, or you can go to the question section and type in your question and we will read the question. While you're doing that, I think I'll start out the questions with one. This innovative system looks very effective, really interesting, but I'm wondering, how much does a system like this cost, Randy?
Thank you, Ann. That's a great question. And I knew that was going to come because it's a fair question too. And so when we started our house, we set out we had 8 specific goals, one of which was to be completely off the grid, another was to be downtown. But a third important goal was that we wanted to be able to build this house for what would be a conventional budget for a new house in our market at that time. And we didn't quite meet that goal, but we were really pretty close. And the reasons that we didn't meet it actually had a lot to do with the various certifications that we went after, including the living building, a very, very rigorous green building standard. There are now 4 living building certified houses in the world, and we're one of them. And there's a reason there's only 4, because it's really difficult. However, including all of that, we were still only a little bit above kind of market rate around here. So as we analyze those numbers, the cost of our system effectively was offset by the costs that we avoided. The system development fee to hook up to city sewer and water, and then the costs associated with digging up the street, digging up the alley, bringing those utilities into the building, and a few other costs. But it was more or less a wash. And So, and also, as I mentioned, we've really kind of overbuilt the system, so we can make them smaller and less expensive at this point. So that's kind of, it's a trade-off. And that's really what a lot of this is about. It's not about building a conventional house and then layering these other things on. It's about rethinking the whole system, rethinking everything from energy to water to solid waste to how much trash we take out to what it's built of. And when you put all of those things together with the goal that you're not trying to spend more money, it's you end up not having to, because you trade things off. There are things we didn't have to pay for a mechanical system or air conditioning or ductwork or all that stuff. We put all of that money into the building envelope, to better windows, to serious amounts of insulation, making sure the building was very tight, things like that. So the same thing is true with the water. We offset that with avoiding the standard costs, which of course would only have been the first cost. There would have then been the ongoing expense of the water itself. Our water's free, so no bill there.
Great. Well, thanks so much, Randy. Okay, lots of questions coming in here. Travis asks, in Montana, quote, water rights are a very contentious issue. So on a small scale, this system seems like a great solution, but if every home in a community were storing all this rainwater, would we be facing water rights issues due to consumptive use?
Well, the thing is, we do collect, well, we only collect the water that falls on the roof. The water that falls on the ground on our site just soaks into the ground, and any water that falls in the streets or open spaces is going to do what it does. So we are recharging the aquifer. So, it's an interesting question, but I frankly don't think that should really make a lot of difference. There would still be a lot of water that's not going to land on a roof, that's going to end up back in either in the groundwater or in the aquifer. I can't say that I've got any definitive studies to prove that, but if you really take a look at how much of a city, how much of the surface area is roof compared to how much is not roof, and if every building in the city could take care of itself from what lands on it, then you're also not withdrawing, in our case, water, a significant amount of water from the Yellowstone River. And we're also not having to distribute it all over the place. So you've saved all those costs, but you've also retained the flow in the river. If you're currently using a lot of wells, then you're not going to be drawing off the aquifer either. So I really think it's like a lot of these things, when you start to really get into it, it doesn't exacerbate the problem, it really mitigates the problems.
Very interesting. Thanks, Randy. Okay, next question is from Sky, and she asks, can you speak more on how you keep the annual gardening so water efficient?
Well, the first thing about the water efficiency is just simply the fact that it's all drip irrigated. And, there's been a lot of trial and error, and I will say that that's really the case with all this stuff, because I'm definitely a jack of all trades and a master of none, but we try things. And so but the drip irrigation has proven to be really effective. So we only direct as much water to essentially to each plant or to each area of the raised beds as we need. And we can adjust volumes. We can tweak that during the course of the summer by either increasing the volume of water, we increase the time that it's on, or we can add water twice a day or any of those kinds of things. So, but we can very carefully control how much water we use, and it's all delivered right to where it needs to be used. And so the plants, frankly, just thrive on it. It's kind of amazing to me. And so, and by not having any lawn, we're not spraying water anywhere. There's no point in that. And so we're able to water trees and our shrubs as well as the plants very efficiently, just by tailoring the amount of water that's needed to what the particular plant is, or that's provided to the plant so I hope that answers the question.
Yeah, great. Thanks, Randy. Okay, next question is from Alexandra, and she's wondering, would designing for a family of 4, for example, fundamentally alter your design principles and she's wondering about peak demand and rhythm of consumption, etc.
Well, we could easily have a family of 4 in here, and it wouldn't change anything. That's where, you would want to, if we really wanted to condense our water storage, then down to really just what the 2 of us need, there would be very little left. I mean, we wouldn't have that necessarily that capacity. Right now, we've had as many as 16 people stay in the house. They were unfortunately for funerals, but the kids, when they came home, were all really interested to see how much the water went down in the tanks during the several days that they were home. And, we're all living the way that we all live and take showers and do those kinds of things. And they looked at the tanks before we started and they looked at the tanks afterwards and couldn't tell any difference. Now, we certainly use some water, but it's, and we're not going to have 16 people living in the house, but it's so efficient that you could easily have a family of 4, a family of 6. Maybe then you'd want all of this water, but there's still plenty, and it still doesn't take any more rain to fill it up. It's based on the size of the roof. It all depends on your collection area, of course, but we have the roof that covers our house and garage is of a size that it only takes 3.5 inches to fill up those 7,500 gallons. So at this point, we could also, we tried when we designed this system in the beginning, there were a lot of resources that we looked into. It became very clear there was more about art than science, and it also became clear that you're really trying to solve for essentially an infinite number of variables. So you start to have to use your judgment. And we tried to do that too. And again, we really overbuilt the system. So we can tailor these much more particularly. Our house really is big enough to be certainly a 4-person or 5-person house. And we would still reduce the amount of water that we currently store if we were trying to really optimize the system.
Great. Okay. Next question. Heather is asking, how do you keep the gutters from freezing up? Our household runs off of all rain catchment as well, but we struggle with that every winter.
How do I keep them from freezing up?
Yeah, the gutters from freezing up.
Well, I'm going to go back to what I said earlier, that we can collect snow melt, and we do to a certain extent, but our gutters will freeze up at certain points too. And also we have snow that slides off the steep part of the roof. So it's really the snow that ends up on the garage and the garden room, which is the flat roof, that we're able to collect. And we certainly do collect some, maybe even a significant amount of that water, but because that snow is on a flat surface, it doesn't, if it hasn't blown away, the temperatures have to be warmer before it really starts to melt. And I think the ice melts in the gutters at the same time. The thing is, at least in Billings, the driest months of the year on average, and averages don't necessarily mean a lot, but nevertheless on average are December, January, and February. So even though we don't get everything that we had anticipated in the beginning, it hasn't made any difference for us. Now, again, I suppose if the whole roof was sloping and you didn't, and it all slides off, then that might be a problem. But we get through the winter. Again, the tanks will tend to go down a little bit because we don't collect all of it during that period of time. But as soon as it starts raining again, they fill right back up. So, there's lots of variables. So depending on your roof size and orientation and all those kind of things, obviously that's going to impact how much you can gather from that location. But in terms of the gutters freezing, ours do too. And it's not a noticeable problem for us.
Okay, great. Lynn and Emily ask, how can you adapt a home that is already built? What are the highest impact modifications that a homeowner of a conventional house can make along these lines?
Well, if we're talking about specifically water, there's some really simple things that a homeowner can do with an existing house. And starting with, look at your toilets. and then go out and buy some Niagara toilets, which they're dual flush that are down to an average of 0.65 gallons per flush instead of 1.6, which is has been the standard for a while, but there are lots of toilets that are older than that that might be flushing with up to 3.5 gallons, sometimes even 5 gallons of flush. So that's the easiest thing to do. And it's really simple. Call up a plumber and have them bring out a new toilet, put it in, but look at the volume, and it should be less than 1.6 gallons because they're out there now and they're not particularly expensive. The second thing, which is not expensive at all, is changing the aerators on the lavatories and particularly on the shower heads. And I think that hardware stores are going to need to do sort of a lending library. We did that internally in the office where we got a lot of different shower heads, low flow shower heads, and we tested them all. And so we ended up with a 1 gallon per minute, which again is only 40% of a code allowed shower head, provides a perfectly comfortable shower to the point that I really don't like showers that have more water coming out than that. They just feel wasteful and they're not pleasant. So you could try some out. There's lots of shower heads now, some even less than that. But certainly around the 1 gallon mark, there's a lot of things on the market now that are very effective. And you're going to be reducing your water consumption significantly. The third thing is taking a look at the kitchen faucet. And that's a little bit more difficult because, of course, there's some advantage if you're filling a pot with water to, being able to have 2.5 gallons a minute. But if you can get one that's 1.5, it's not going to delay your pasta water that long. And again, will tend to reduce your water consumption a lot. So those things you can do in the house. If you do all of that in a typical house, you're really talking a few $100s. We're not talking thousands or tens of thousands of dollars to make those changes. And then the next thing, which is, as you saw from the Billings numbers, where we end up jumping from 86 gallons per person per day to 120, 130 gallons, that's all lawn watering. So if you get rid of grass and put in native plants, gardens, do things that you can drip irrigate, you can dramatically reduce the amount of water that you're using in that area as well. And that's before you do any of these other things that we did internally. You can also, as a simple move, just collect rainwater into rain barrels that you just use to water plants and garden areas it doesn't have to be plumbed or anything. Just put in rain barrels, and that can be a help. And so those are kind of the first things that are super easy. If you want to get into something further than that includes storage and so forth, then there are ways certainly to modify an existing house to accommodate that. That's going to be more of a case-by-case basis. But we've been thinking about those kinds of things a lot. And there's lots of ideas for how to do that. And again, it just really depends on the house. Do you have a basement? You don't have a basement. There's just different strategies that will be brought to bear depending on the circumstances. But I hope that answers the question. But there certainly are a bunch of things you can do as a first step that will really significantly drop your water consumption and then rethink the landscape. You do the interior things and those exterior things, and you're going to see your water consumption drop significantly.
Oh, that sounds really good, Randy. Okay, we have lots more questions pouring in here. Bonnie is asking, can gray water be used by commercial businesses in Montana? And I was busy reading questions, but maybe sort of answer this. She also wonders, can an existing home be upgraded to at least collect and redistribute gray water?
Okay, so the gray water situation is a little bit trickier, although I will say, and I had it over here, but anyway, the new building codes are actually recognizing rainwater systems and gray water systems. That's the 2021 edition of the codes, which the state of Montana has not adopted yet. However, we can use those generally as code evidence with building officials when we're talking about these kinds of renewable systems. So we really like gray water. We're doing a project in Roundup where we're going to, it's an apartment multi-unit building where we're going to collect some of the gray water. We can't even use all of it, but we're going to collect some of it because we do have a little bit of irrigation outside. So we're going to treat that water and use it for irrigation. We'll also use it internally for toilet flushing because we don't have composters, can't really accommodate those. So we want to use reused water for toilet flushing. So yeah, we can use it in commercial applications. We can use it, and it can be used in retrofit cases, but I can't just, there's not a one answer fits all in a retrofit. It really just depends, again, a lot on what your particular circumstance is. I hope that answers the question.
Yeah, thanks. Travis is wondering, do you allow yourself the luxury of a hot bath on occasion? Is a hot tub an unrealistic luxury considering the water shortage realities we are facing?
Well, the hot bath thing, we do have a bathtub. I never use it. I have kind of a fear of bathtubs after I broke all my arms at one point. So, but yes, you could use it. In fact, we designed a house where the wife wanted to take a hot bath in this fancy 80-gallon bathtub every day. And so you can build that in. Now, that was a new house, and so we kind of created its own, without, you don't want to duplicate everything, but we did figure out a way that we could capture all that bathtub water and recycle it. So, but certainly if it's an occasional thing, that's not a problem at all. And the same thing with a hot tub. If you're not changing the water every day, I don't think that's, again, in our case, it wouldn't be a problem. We wouldn't even notice. I mean, we actually overflow already so much water that if we had a hot tub, and obviously you have to refill it to a certain degree all the time, but not the entire thing. I don't think it wouldn't have any big impact at all in terms of our ability to be self-sufficient.
Cool. Well, this next question sort of goes along with the hot tub issue. Alex is wondering, do you have battery storage? And that is, when the sun doesn't shine, then what do you do about your electricity? Okay,
so totally good question. We have some batteries right now because we have a hybrid electric system. It's half low voltage DC, and that runs all of our lights, ceiling fans, pumps, that kind of thing. And then we also, the other half, the plugs, are AC, standard voltage AC. So that's the appliances and our plug loads. Although a few of the plug loads we have converted to DC as well. But anyway, so we use a lot less electricity. But as I mentioned, so currently we do have a grid tied to Northwestern, but we produce more on an annual basis than we use. So we're net positive. And we're working hard to get to the point where we can take that Northwestern connection and pull out all that copper and recycle it, and make up the difference with batteries. And so for us, as we've gone along here, and this is really true everywhere in Montana, it only gets slightly more extreme as you go further north, but we have, we generate a lot of electricity between January 21st and November 21st. And those 2 months from November 21st to January 21st, we just go through this hit. And the sun's too low, the days are too short, we really can't generate a great deal of electricity. We do generate some. And so we're working on a variety of strategies to get us past that, because the other thing at that point when we don't have as much sun, it's just the middle of the winter, and so it's colder. And we're working on other ways to address that at the present time. As I mentioned, we don't have a heating system, but we do have some backup electric heaters that are used on a kind of individual basis, depending, in the room that we're in, we'll turn a heater on if it's cold enough. But we don't heat the house with it. We don't try to maintain 70 degrees or 66 degrees or any temperature. We just we'll turn on heat when we're in that space. And we're gradually getting better. So we've added some solar air heaters just this January. They finally got installed. And this is kind of an amazing device because It's just a flat panel, vertical flat panel. We mounted it, 3 of them on the wall. The air coming in at the bottom of the panel, which is about 5.5 feet tall, will be room temperature, and a few seconds later it comes out the top, pushed out the top with a solar powered fan at somewhere between 115 to 125 degrees. So it's made a huge difference already. And now we're looking at doing some other things with our ventilation system air, where we're maybe extracting heat out of our gray water tank and putting it, after running it through a heat pump, or using the gray water as the source with a heat pump, and then having a heating coil in the supply air stream on the ventilation system, so that, because that system runs all winter long, so we have very constant temperatures in the house. But if we could boost that temperature right at the HRV, then we can really take care of ourselves. And so that'll help us get through that low spot. And at that point, frankly, that's when we're going to be looking at what do we need now for batteries, because we've got the heat source with the gray water is always there. The supplemental source with the solar panels is there. So we got to figure out how much energy we need to store to get through that period when we don't have as much sunlight as we do during the rest of the year.
Great. Okay, I see we're getting towards the end of the top, or getting towards the top of the hour here, so I'm just going to take maybe 2 more questions. Here's another one. When you use gray water for irrigation, do you need to use all biodegradable soaps? And what sort of lifestyle changes have you had to make to be able to use your gray water for irrigation?
That's a good question. And I will say that when we started, well, and we still are, frankly, we were very concerned about what we're putting into our water, because now whatever pollution we put into the water is completely dependent on us. And so if we want to mess ourselves up, then we don't pay any attention to what we put in it. However, so it's been a lot of researching different products, but it's not something that turned out to be burdensome at all. I mean, there really are, if you look, the kinds of shampoos and soaps and things, dish detergents, laundry detergents, all those things, you can find products, and they're not hyper expensive, and they're not only special order or any of that kind of thing, but you just have to look for them that are largely biodegradable, but certainly non-toxic, and so that don't create any issues with the plants. And we haven't had any problems, nor do we feel like we've been burdened with having to be on some kind of very specific protocol in order to avoid problems. I mean, it's not that big a problem. We do pay attention, but there are lots of options. And so kind of the first thing is to just recognize you need to pay attention. And if I could digress for just a second, with the Living Building Challenge, the most difficult part of that process, which by the way requires what we've done, essentially you've got to generate all your own power on site, collect all your own, and treat all your own water on site, grow a significant amount of your own food, and so forth. But it also has what is it's a materials pedal. So you have to vet all of the materials that you put in the house, everything, and it's all has to be documented. And I thought, okay, we're going to really try to limit the palette, limit the diversity of things that we put in. That'll help. But it was really, really challenging. And you start to, and they have a red list, they call it, which is starts out as a list of 30 or so chemicals and compounds and elements that are known bad actors. I mean, things, a natural element like lead, you don't want lead in your house. But other things like PVC, vinyl, are stuff that are just really not good for you. And there's a million, and this 30 then of course makes a lot of other compounds that are mixed into things all over the place. And when you start really studying what building materials are made out of, I mean, at the beginning I thought, well, this is ridiculous. So there's nothing that doesn't have some of these toxic materials in it. That's not right. That's not fair. We can't make it work. And then I thought, well, wait a second. Why is that? We shouldn't even have that problem. These things shouldn't really even be made. And so we really went after that one and worked really hard. to find things that we could use that didn't have any of this nasty stuff in it, which is just pervasive in our climate, in our culture, in our environment, in our economic system. All stuff that really should never have been made in the first place. Most of it is not natural. Lead is natural, but most of it is not. And so these are things that we've figured out how to make, do something. There's no requirement that we test that. For the most part, there's very little requirement that you ask any questions about it, except, oh, wow, this makes a great cleaner. The fact that it's going to kill you if you use it for 6 months, well, that if it starts killing people, then we get interested in examining what's happening. So there's a lot of problems with our market the way it works right now. But from that experience, we just pay a lot of attention to what we buy all the time. And so that certainly applies as well to things like that we use personally within the house. We just don't want to mess with that stuff. We don't want it. So, and we don't have to have it. So we pay attention, we don't buy it.
Okay, well, we're on to our last question, which is a really interesting one. So here it is. So many of these solutions seem available only to homeowners. This leaves younger and lower income people feeling powerless to affect change and save money by being more efficient. What can renters do to help press their landlords to upgrade to more efficient toilets and appliances?
Well, that is an interesting question because on the one hand, I want to say that these things aren't only available to homeowners. We're looking at doing multifamily buildings. We're looking at doing what we're calling small, high-performance home kits that will incorporate all of these kinds of things. But if you're already a renter in a building that's not efficient, that is a good question. I guess I'd just start lobbying. I mean, I'm a landlord too. We do try to build our buildings and incorporate these kinds of things from the beginning. But if I was a landlord and I had tenants that are really demanding some of this stuff, and there's an option in town because somebody else is doing it, and their building seems to stay full because every time there's an opening, somebody moves out of my building, I'd get motivated. I do think that's a really excellent question. I do think there are also probably some incentive programs that could be created to help make that happen. But it's really going to be up to the property owner, I think, up to the tenants to become aware and say, you know what, we need better than this, and we deserve better than this. And frankly, what ultimately happens is that it reduces the cost of ownership, it reduces operational costs, it reduces maintenance costs. It's a virtuous thing. Cycle. We get into, we just have all these systems to take care of that are really complicated, or they're really inefficient and they cost a great deal to operate because of the utility costs. And so it's an excellent question. I can't say that I have a total answer to that because frankly, that's, I think, the first time I've heard that particular question. So I'm going to think about that. But I do think there's some ways, and if we don't have a way yet, we need to figure one out.
Okay, well, Randy, I think we're going to wrap it up here. And we just wanted to thank you again so much for sharing all this conversation with us and all your innovative ideas. We really appreciate it. And we're going to say goodbye. And I just wanted to thank all of you for joining us this evening. I hope you really enjoyed it. And please look for a follow-up email that will be in your inbox in the next day or so. It will include a link to a recording of tonight's talk and will also provide information about some future events. Once again, I just want to remind you to go to our website at www.gallatinvalleyearthday.org for details about upcoming events like next week. There's the interesting film and panel discussion called Drop, Water Connects Us All. It's about how it'll be some really interesting conversation. Again, I think about how a warming climate can have consequences for us all and include some really interesting people from Montana. Again, that's Wednesday, April 13th at 7 p.m. And also, we just want to invite you to come out and see us in Bozeman here during Earth Day week, because we've got a number of really fun events. Thursday, Earth Day week on the 21st. They're showing a really interesting film at the Emerson. The doc series is a partner of ours. It's called River. And then on Friday, you can celebrate actual Earth Day with us with a lot of music and some really interesting speakers at the Emerson. On Friday at 6, we have some food and drink and a fun social hour. And then this program begins at 7. And if you want to get out and get a little exercise and celebrate Earth Day and raise money for our schools, head over to the Earth Day Fun Run on Saturday, April 23rd. It starts at 9 at the Gallatin County Regional Park, and you can register online at our website. And then, of course, please come and have lots of fun at our annual Earth Day Festival at the Emerson on Saturday, the 23rd. It starts at 10, it goes till 3, and it's a little of something for everyone. We've got local foods, live music, exhibits outside and inside, short films, talks every hour, and bring your kids because we're going to have a really special program at 10 and 10:30 in the Emerson. It's called the Magic Monster Show. It's a free improv puppet show. It'll be loads of fun, and we also have prizes and other activities for the kids. So lastly, just thanks again for coming. If you'd like to be kept up to date on our Earth Day activities, you can go on our website and sign up for our newsletter. And please enjoy your evening, and we hope to see you again soon. Good night. Thank you.